Hello everyone, my dear class. Hope you all are doing good, doing wonderful. In this session, I'll be discussing chapter number 3 from the Cisco Networking Academy. And so let's get started. Let's see, teaching screen. Okay, now you should be able to see me in the inset. And let's see. Okay, concurrent viewers 2, chapter number 3, 3.1. Let's get started with that. Okay, in this chapter, chapter 3, titled as Dynamic Routing, we are discussing how routers can learn about best path, how routers can learn about routes and build their routing tables by talking to other routers using some protocols dynamically, automatically, without you having to manually write down the routing entries. Okay, that is dynamic routing. That's what we're going to discuss today. And there are so many protocols that are in the dynamic routing. For example, this RIP, Routing Information Protocol. That is one. You got uh, EIGRP, Enhanced Interior Gateway Routing Protocol. This EIGRP or IGRP, Interior Gateway Routing Protocol, they are developed by Cisco. I'm talking about the IPv4. Okay. Now IPv6, don't worry about that at the moment. So EIGRP. Then you have link state, but this one distance vector, meaning it goes by distance. It calculates the best route by counting hops. A destination network, how many hops away, how many routers away in this path, as opposed to how many routers away using the other path. It just counts the hop count. That's why it's the distance vector. It does not count which path has a faster connection. But the link state on this type of dynamic routing protocols, they do, such as OSPF, Open Shortest Path First, or ISIS, Intermediate System, Intermediate System. Then you have some other kind of routing protocol. They discuss like connecting to different network, okay, like two ISPs, two different types of network. Two ISPs are connecting. Those are called exterior gateway protocols, like BGP, border gateway protocol. Okay, so let's see what we're going to discuss in this chapter. Let's move on. The next slide. Okay, dynamic routing protocols. Okay, no worry about it. Data structure. Okay, basically we're discussing in this slide that in the routing table, when the routing is being calculated, route is being calculated, then at that time they use several kind of mechanism. One is the data structure. There's a database about the routers, about the path. That's kept in the RAM. Okay, the protocol messages. Like say you're using RIP. So RIP, advertisement, sending, receiving, that will be the messaging. That takes place. There is then number 3, an algorithm, a formula, a mechanism, okay, that is used to calculate the route. So some information, that's the data structure, some messaging between each other, and some algorithm is used. Let's move on. Okay, static routing usage. Now this is something I need to pause a little bit and discuss the basically advantage, disadvantage between the static and dynamic. Okay, so these coming slides will be discussing that. The static routing advantages and disadvantages. Let's talk about that. Okay, easy to implement in a small network. Now we're talking about static routing. Static routing meaning where you manually write down the routes. It's easy to implement for a small network, understandable. Another advantage is it's very secure because this router is not talking to other routers all day long uh, and learning from each other. When it learns from each other, a hacker may pretend to be another router and send some advertisement and mislead my router. Therefore, it is in the dynamic routing, it is less secure because where router is having to talk to other routers and learn routes from other routers. But in static routing here, it is secure because no advertisement, no chit chat between routers are going on. Number three, route destination is always the same. Whether even though your network topology has changed, you have added more devices or changed the path, whatnot, but your destination from your router to the destination network path always remain the same because you manually wrote it down. It's not changing, it's static. Number four, no routing algorithm or update mechanism is required. So there is no calculation required. You are manually writing down. Therefore, no extra CPU RAM being used. Is there any disadvantage of static routing? Yes. It's suitable for only simple technologies for special purpose, such as a default static route. For some purposes, like writing a default route, that one would be easy with the static route, but not always. So only for a simple technologies, simple situation, like a stub network, like a very simple network. Okay. Number two, configuration complexity increases dramatically as network grows. If you have like just four routers, a small network, a static routing is perfect, ideal. If you have 70 routers, then static routing is a nightmare. You want dynamic routing at that point. And lastly, manual intervention required to reroute traffic. If network topology has changed, if path has changed, router is not going to automatically update because you're doing static routing, manually writing down. So you have to manually go again and change your route. Next. Okay. Dynamic routing protocols. Now look at this scenario. I have 1, 2, 3, 4, 5, 6, 7. 7 routers. And I'm doing the static route. Fine. Look at the second picture. Now my network has become bigger. I have many routers, 28 routers in this case. It will be a very serious, seriously hurdle to use the static routing in this situation. Too many routers, too many paths you have to write down. It's not even worthy. It's not even, you don't even want to think of that. Next. So we need dynamic routing in this. So dynamic routing advantages and disadvantages. Let's see the advantages of dynamic routing. It is suitable in all topologies where multiple routers are required. Yes, it is suitable for big, small, everywhere. In small network, why do we choose static? Sometimes because it's the simplicity. I don't have to configure all those protocols. That's why I use static. But it's medium to big, you want to use dynamic routing. And of course, a few lines you want to write statically as well. Generally, number two, generally independent of the network size. Yes, no matter how big the size is, dynamic will take care of it. Number three, automatically adapts topology to reroute traffic if possible. Whenever the router path changes, okay, any kind of change happens to router to the topology and path, and it does all protocol. You don't want to use the RIP protocol anymore. You type no router RIP. That's what you would type, no router RIP. Let's look at the screen number 2. Okay, screen number 3. From the privileged exec mode, you go to the config mode, global config mode, and then you type router RIP, and you are in the configuration mode for RIP. Okay, good. And what commands are available in RIP? Okay, these are the commands available in the router configuration mode. If I open up packet tracer, for example, some of the items I'm going to show you in the packet tracer. I go to router and 1941, that router I'm going to put in here. This is my router, and router is booting. Okay. Here I am, enable mode. Okay. Now, if I go to config T, I'm in the global config mode. And then what I want to do, I would like to go to the RIP configuration mode. So I type this command, router RIP. Okay, that's the command I type. Press enter. Now, if I want to know what are the commands available in this, mode, in the router mode, RIP mode. So I'm going to type a question mark. So I see, oh, okay, in this RIP configuration mode, I have, these are the commands: auto summary, default information, distance, exit, network, no, passive interface, redistribute, protocols, things like that. Okay, and version. So we'll be using some of those in the future as we talk. Okay, let's move on. So that's what it's showing here for you. Next, okay, advertise network. So how do I advertise my networks to other routers using RIP? Okay, so here is what we do. We use this router RIP. We go into that mode from the global config mode. Then look at this router R1. I'm in the R1 right now. R1 has two networks. R1 has this network right here, 192.168.1.0 and 192.168.2.0. These are the two networks connected to R1. So R1 wants to advertise those two networks to all other routers. Okay, to all other routers. So all other routers will know that, okay, for those two networks we have to go to R1. So he went to we just entered into the RIP mode, and then we type network and the network address, network and the address. That's it. That's how you advertise the network. Okay. Now they want you to practice, which you want to practice yourself at home. You can click show me or show all, and you see how they have done it. Okay. Next, verifying RIP routing. Once RIP has been configured, how do you verify? How do you check? You use the show command, show IP protocols. Okay, show IP protocols. If I go here to my router, I'm in this mode right now. I'm going to press end to go back directly to the privileged exit mode. Here I am. Show IP protocols. Okay, show IP protocols. Okay, that is the command that you will be using. Mine is not configured. I have not configured anything. No network, no interfaces. So you're not seeing all the output. But that's the command. Show IP protocols. Okay, show IP route, that shows the routing table. We know that. We have done that in the last chapter. And they want you to practice. Move on. How do I enable and verify RIP v2 version 2? RIP version 2. So all I have to do, I have to go to the RIP mode and I type version 2. That's all I have to do. Easy and simple. Here I am. Look, I'm in here. I'm going to go to again config T. I'm in the configuration mode. I'm going to go to the RIP mode. So I'm going to say router RIP. Okay. Here I'm in the RIP mode. In here, I would like to enable version 2. So ver tab version 2. Version 2, enter. That's it. That's all I have to do. Then version 2 is enabled. That's simple. This one is an easy chapter, my friends. We're going to move on pretty fast, pretty good. Okay. Now disable auto summarization. What the router does, router makes a summary of the routes. Okay. For example, say you have, let me open the Microsoft Word and tell you something that may be easy way to explain to you. Okay. Say I have a destination network, 192.168.2.128, and that has say 26-bit mask per se in this. Okay, you might understand if you remember all those subnetting that originally this was 192.168.2.0. That was originally what I had with a 24-bit mask, correct? It's a class C. This one is a class C IP address. Therefore, by default, it should have a 24-bit mask. And we know that only the last octet we can change. I'm repeating very much. I taught you in the chapter one, semester one big time, and I'm sure you all understand. But I'm just still trying to catch you up with that, help you catch up. So then I did subnetting. By doing subnetting, I created one subnet here, say 192.168.2.0 network. That's one. That maybe, say I did this one 25-bit mask. Okay, this one 26-bit mask. I can do these kind of things. So I can do various kind of subnetting. I'm not going into the detail on that. You understand that. Now what happens? If this is a network and this is another network, do you know what's going to happen? These two networks, summary network is going to be this one. Okay, that's called the summary. These two networks are subnetted from whom? From this original network. That original network is called the summary network for these two. So that's what I wanted to tell you. So let's go back to the chapter. Okay. So sometimes this summarization would be unhelpful, because when router would summarize, what's going to happen? Just think of this. Say these networks right here. This network is connected to, per se, R1 router, and this other network, another subnet, a separate subnet connected to R2 network. Then what's going to happen? By summarizing, R1 is going to say this whole network is with me. R2 is going to say this whole network summarized, and that network belongs to me. It's going to be very confusing. So sometimes you don't want to summarize. You want to keep it exactexactly as is. Say, hey, R1, you only have this network. And hey, R2, you only have this subnet. That's it, smaller subnets. You don't have the whole network. You only have a small subnet. So I want to disable the auto summary. So what I do, I use the no auto summary command. Okay, and so that's what they're telling you, that you use no auto summary, this command right here, so that it will not summarize the route. It's going to keep the route as is. And let me show you by typing the command. See, I'm in the RIP mode still. I just enable version 2, and so it's going to be always now version 2. Now I would like to say no auto summary. What I do, just type no and just type AU. See, no auto summary. Tab. I press tab. Boom. So it will no longer summarize in the RIP. This little command they're going to show you, teach you in this here. See, it shows no auto summary. Now they want you to practice. Let's move on. Configure a passive interface. You may say, what is that? What is a passive interface? Well, let's look at this scenario right here. Let's look at R1. R1 has two networks connected. Look at on my left side. Gigabit 00 interface that only has a network right here, this network, 192.168.1.0. On the serial interface, it has 192.168.2.0, that network. Only these two networks R1 has. Now, R1 is going to advertise to all other people in the world any way it can that, hey, I have those two networks. Hey, I have those two networks. So for those two networks, come to me. R2 is going to say, I have this network right here and these two others networks. My three hands are connected to three networks. Those three networks belong to me. Okay. But just think this. Why would I mean, when R1 is going to advertise through this serial interface, who is going to listen to? that advertisement. R2, that's another router. But when R1 is going to advertise its routes to this way, there is no router in here. It's just a dead end. It's just a network. Only some computers are connected here. Some PCs, some IP devices, whatever end devices are connected here. There's no more router this way. So I say, hey, R1, don't advertise your routing path via gigabit 00 interface, because this gigabit 00 interface does not have any more routers. Nobody needs to hear your routing advertisement protocol. Okay. Uh, so I would say, let's make this LAN interface a passive interface, so that RIP, router information protocol, advertisements will not be advertised via this way, because it's useless to make this interface busy for no good reason. For R2, same way. This LAN interface right here, gigabit 00, I'm going to make it a passive interface. So RIP advertisement will not go through this way. Only it's going to go through this way to other routers, only go this way to this other router. Okay. So only routers need to know the advertisement. So I can configure this gigabit 00 interface as a passive interface. How do I do that? Okay. So let's look at that. Okay, use this passive interface that command. Okay, very easy. Let's see screen number 2. Look at here. It says passive interface gigabit 00. Okay, passive interface gigabit 00. That's what it did. It wants you to practice. So I could go here in my router, and I just did the no auto summary, and I'm going to write passive, just PASS tab, passive interface. Which interface? Gigabit 00 per se. That one is my LAN. Okay, that's it. So simple commands. Next. Okay, propagate default route. Okay, think of this now. Say, let's understand this scenario very well. I have 3 routers. I have R3 that has a LAN, local area network connected. I have in the middle this R2 router, has some LAN also. R1, R2, R3, 3 routers. All of these people, if they wanted to go to the internet, how do they go to the internet? They have to go through R1, because R1 is the one connected with the internet. So for all these routers here, all this network here, all these PCs here, if they have to go to the internet, they have to go through R1 and then go to the ISP and get connected to the internet. So there has to be a default route. All the outside world, unknown, all these unknown destination networks which are in the internet belong to the other companies. For those networks, for those destinations, you want to create a default route, and that route should go through this R1 interface. R1 has this, serial interface, which is maybe serial 001 interface, I guess. Serial 000 is here. Maybe this one is serial 001 that connects to the internet, and its IP address is .1. Okay, so let's see. So how do we create a default route? We already know that 0.0.0.0, that will be the network address. Subnet mask will be 0.0.0.0. We have done this in the last lab. So now, then how about you're going to go to the R2 and do what? You're going to also write another default route in the R2. You have to manually go write another default route on the R3. You don't want to do that. You say, okay, I already wrote down default route just one time in this R1. Why can't R1 convey this information to other routers in my company? So R2, R3, they will all learn about this default route. Yes, you can do that. You can have R1 advertise the default route to all other routers. So you don't have to manually write down everywhere. How do you do that? You type default information originate. That's the command. Let's see how we do that. Screen number 2. Look at here, default information originate. Okay. So first he wrote down a default route. and then he typed this command default information originate. Okay, so here manually they wrote down an IP route and then type this command default information originate. Of course, we're going to have labs, we're going to do that. For my router, I have not done any IP addressing, so I have not done a default route yet, so I won't be able to do that right now to show you. Okay, if I want to go exit from here and type here, say default route, IP route 0.0.0.0.0 0.0.0.0, and then say goes through gigabit interface 0, 0. Okay, that's the default route. And then if I want to type default information originate, so this default information will be advertised to other routers. So how do I do that? I'm going to type router RIP to go to that router mode, to go to the RIP mode. Here I am. I'm going to type default, just DEF, so default information originate, OR, originate, enter. That's it. That's how we do it. Okay. Next. Now packet tracer configuring RIP. We'll do that at some point, I guess. Configuring basic RIP version 2. Routing table now, looking at the next, looking at the routing table entries. Okay. By looking at the routing table, let's understand those entries. What do they mean? Okay. Here is a routing table entry. Okay. We're seeing so many lines. We need to understand what this line means. We kind of know, we already have discussed. I guess it's going to be repeat, sort of. So next. Okay. If there are some directly connected entries, so for the directly connected entries, we have there is how they look like. Okay. These entries are automatically created by the router. 172.16.1.0/24 is directly connected. Exit interface is gigabit Ethernet 00. That's how it is in the router. So what does this C mean? C means directly connected. L means local interface. Okay. And another one, C here. C means directly connected network. 209.165.200.224 30-bit mask. L meaning local interface. This network is connected to this interface. The interface's IP address is .225 and serial interface 00. This is basically serial interface 00's IP address. That's the local interface. So always remember, C means directly connected network. Okay. Okay. So here, the first, item, that is a letter, either C or L. C means directly connected network. L means local interface. And here is the outgoing interface. Here's the destination network. So this is the network that is connected, and this is the IP address that is attached to that interface. Okay, simple enough. Next, so they are telling you what is this S, D, O, R. Okay, well, C means directly connected. If it was S, that means it's static. That route was manually written down, not directly connected. If it is D, that means this route was learned by EIGRP protocol. It's a dynamic route learned by EIGRP protocol. Okay. Then if it was O, it was learned by OSPF. That's another protocol. If it is R, then learned by RIP. So this T, O, R, these are all dynamic route. If you manually write down the static route, it's going to show an S. And if you did not write, router automatically wrote down something because that is directly connected, then it's going to have C and L. Okay. Next. Okay. Now remote network entries. The network entries, the networks that are not directly connected to you, those entries are going to have like this, what we already have discussed. R, for example, That shows the route source. How was this route learned? It was learned via RIP protocol. That's why it shows R. Which network are we talking about? Which destination network? This network. That's the destination network. What are these numbers right here? One is administrative distance, one is metric. Administrative distance is 120. Remember, administrative distance, for it, the smaller number is more reliable. What does the administrative distance say about a route? It says how reliable that route is. The lower the administrative distance, the more reliable the route is. So directly connected routes are the most reliable, should have 0 administrative distance. If you manually write down a static route, it should have 1 administrative distance. If it is learned by RIP, then of course 120. Here is the metric. Metric is a number that router automatically calculates out using some other factors. We don't discuss those factors here. Again, for the metric, the lower is the better number. Okay, for a directly connected route and a static route, the metric is 0, meaning that's very good. Okay. Next hop router. You have to go through this next router. Its IP address is this. How long has it passed since this route has been updated, has been learned? That's the time. Which interface do you have to go out to go to that network? Serial 000, outgoing interface. So that's what it is. Next. Let's do this little activity. Okay, I'm going to at least do a few just to show you. I don't have to go through all of them for the time. Okay, what about this network? 10.4.0.0.16 for that network. What is the route source? What is the administrative distance? What is the metric? Okay, so 10.4.0.0, look for that network in this table right here. 10.4.0.0 is directly connected. So that's the line here. S. It's a static route. So route source is a static for this. So static. Okay. And what is the administrative distance? Because it's a static, we know its administrative distance will be what? 1. So static has 1 administrative distance. And then metric. We know the static route has metric of 0. Okay. How about I do one more for you? 172.16.2.0. Look for that one. 172.16.2.0. 172.16.2.0 right here. This one is directly connected. Okay. 172.16.2.0 directly connected. So directly connected means connected. So I have to use this one. What is its administrative distance? 0. Directly connected is the most reliable. What is its matrix? 0. Okay, and so on. So for these two, I can go and check. Yes, it shows incorrect because I didn't do other ones, but what I did is all correct. Okay, next. Okay, routing table terms. Okay, now you need to know some more terms here to understand the routing table better. What is an ultimate route? What is a level 1 route? What is a level 1 parent route? What is a level 2 child route? You got to learn that. These kind of things are in the exam. Even it could be in the CCNA exam. These are some things that sometimes are very confusing for people. So let me discuss one by one. Ultimate, level 1, level 1 parent, and level 2. Okay. Ultimate route. Ultimate route means any route, any line that you see in the routing table that has either an exit interface or a next hop IP address. If you see a line on the routing table that has an exit interface or the next hop router's IP address, that is called an ultimate route. That same ultimate route will fall into other categories like level 1, or level 1 parent, or level 1 parent will not be an ultimate route, but level 1 or level 2 child, they could be ultimate routes too. But that's why all the lines that are highlighted in orange here, all of them are ultimate route. Okay, most of them are going to be ultimate route. So let's see why are these lines ultimate routes. All the orange lines, go line by line, and you see at the end it has an exit interface like gigabit Ethernet 00. Also it shows, look at this line right here, R. That line says via 209, via, that is your next hop IP address. This is your timestamp, and then your serial interface, this exit interface. So these are all ultimate routes. And look at these white lines. These two lines that are in white, they are not ultimate routes. See, they don't have an exit interface. Serial 00 or gigabit 00, they don't have that. Okay, these kind of routes are not ultimate routes. They cannot help you to choose a path or which way to go, nothing like that. Therefore, they have a different reason. By the way, these are also level 1 parent routes. We'll learn that in the right time. Next. What is a level 1 route? A level 1 route has a subnet mask that is either equal to or less than, again, either equal to or less than its class full subnet mask. Either equal to or less than its class. Let me show you an example, otherwise it's going to be very confusing. Let me write it down for you and show you. I'm in the Microsoft Word. Okay, say I have another route here, 192. I have many subnets. Okay, 192. They are all gonna be 20. Okay, 192.168.2 dot say 192 and say 27-bit mask on this. Okay, now think of this. Okay, all these different subnets, this is a different mask. All of these came from whom? All of these subnets came from whom? Came from this one. This was my original network, 192.168.2.0. We subnetted this original network into these three subnets right here with different kind of mask. We have learned this, we practiced this in the past. Okay. Now, what is a level 1 route? A level 1 route would be, this is not a level 1 route. Why? This is not a level 1. These are all level 2 child routes. Because what kind of IP address is this? This is a class C IP address. Okay? Class C IP address. Class C network address. IP network, whatever you want to say. Okay? Class C. How do I know class C? Remember the first number begins with 192? That's going to be class C. We know these things, right? That between 1 to 126 is going to be class A, between 198 and, sorry, 190, between 128 to 191 is class B, and then 192 to 223 is class C. This is class C. What is the class C's default subnet mask? Default mask for the class C is default mask of class C 24-bit. We know that 24-bit. Class C's default mask is 24-bit. Class B's default mask is 16-bit. Okay, so 24-bit mask is the default. But look at these subnets. Are not they bigger than 24-bit? Yes, 25, 26, 27. So they are child. They are level 2 child. And level 1 is this one. Okay, the exactly 24-bit, that's the main network, that's the level 1. Okay, how about this other one? I'm going to give you another network. you have done a supernet. Instead of subnet, I'm talking about something else now. Okay, we didn't learn a whole lot about that. What is not a subnet? Instead of subnet, a supernet. Say 192.168.2.0, that network, but I am subnetting it. Look, 24 was the default. I'm subnetting it in 23 or 22-bit mask. I said, oh my lord, 22-bit mask. Not only that this number is going to be different, even in here something is going to be different. Okay, because in the third octet it's going to be different now. So a whole lot of computer can be done in one subnet. It's a different situation. So that will be also class level 1. Level 1. Okay, so this is level 1, and this one is also level 1. This is also level 1. So these two are level 1. Now, so you don't get confused again. What is the subnet mask on this class C? Exactly 24-bit, the way it should be for class C. That's level 1. How about something less than that? Less than 24? That's going to be also level 1. Okay, that's going to be also level 1. When you summarize several routes in the routing table entry, it's going to become less than the default mask. That's a level 1. What about the subnet mask is more than the default mask of 24-bit? Those are the subnets, the smaller networks. They are the child. Just remember that. If it is bigger than default, then it's level 2. So these are all level 2. Level 2. Okay. So we don't need this R1 thing in here. So that's simple. Okay. If you really look at it, it's a very simple thing. If the subnet mask is bigger than the default, then it's level 2. Okay. If subnet mask is the same or smaller than the default, then it's level 1. Okay. So that's what it is. So let's go back to the chapter. Okay. So level 1, it has to be is equal to the class full. If the subnet mask is equal to the default, then it's okay. If it is less than, subnet mask is the less than the default subnet mask, class full mask, then it's also level 1. Or a default route. Default route always level 1. Okay, 0, 0, 0, 0, all zeros, that's default route. In these 3 scenarios, we have a level 1 route. Either subnet mask is the same as the default, or subnet mask is less than the default, or a default route, regular 0, 0 route. These 3 are called level 1 route. Okay, so look at here. The ones that are highlighted in here, okay, level 1 routes. Okay, here, why this line is white? What is the reason? Number C, this one is C, starts with C, because it's 24-bit mask. Okay, but it's a class B, 172.16. Oh, 172 is a class B. Class B's default mask is what? 16, but it's 24, so it's a higher. Higher is child level. Okay, not level 1. And next, level 1 parent. When you have child present, then level 1 parent would be in the scenario that I have in the same routing table. I have all of these routes present, all of this. Then these are going to be the child level 2, and this is going to be the parent level 1. This is going to be level 1, or we will call it level 1 parent, because children are present. Okay, that's all. So parent route is the level 1 route, just like that, level 1 route, but it also has some children route or child route is present in the routing table. That's all. So here, highlighted 2, okay, are level 1 parent. So since this 16.0.0/16, 172.16.0.0, with the default mask is 16 because it's class B. That has been subnetted. So all these subnets, these are child, these are level 2 child, and this is the parent route. But look at this, the parent route, one thing about the parent route, it does not have an exit interface. It only has it's just like a heading for this, all these routes, for all these routing entries, this is the heading of them. And look at here, for all these routing entries, this orange line is a heading of them. So a parent route does not have an exit interface like serial 00, nothing like that. This is not an ultimate route. Okay. Next. Now, child. I already discussed child with you, that all the subnets are the child routes. Child routes going to have a bigger than default subnet mask. Okay, bigger than default subnet. Look at this child here. This 24, 24, 24, 28 mask, 24-bit mask, 24-bit mask, several networks we're talking about here. All of them are summarized by this route. 172.16.00, that's a parent. That's a parent route. And these are the children route right here. This one has been subnetted with all of this. This one right here, the parent route, it has a 16-bit mask. And it has been further subnetted by 24-bit mask, 24-bit mask, 28-bit mask. These are all children. Look at this other route right here, 209.165.200.0. That's the parent, subnetted into this 30-bit mask, 30-bit mask, 30-bit mask, these ones. And this parent has, since it's a class C, it is a 24-bit mask. Okay, it shows over here, all the highlight, these are all the orange ones are child routes, child, level 2 child. Okay. Okay. Now, let's look at this activity, what they're asking us to do. Instruction. Using the routing table below, locate the networks listed in the chart. Okay, so here's the routing table. So we're going to be locating these routes. Okay, okay. Determine whether the networks are classified as level 1 or level 1 parent or level 2 child. Okay, let's see. 0000. That is what? That's a default route. We know the default route is always going to be level 1 route. It's level 1. Default route is a level 1 route. How about this one? 192.168.3.0. 192.168.3.0. Is there any other 3 dot anything? No, just only this one. That's a level 1. Level 1 route. Because 192 is a class C. And class C's default is 24. Is equal to the default. That's a level 1. How about this one? 192.0.2.64. 192 again is class C, and it has been subnetted to from 24 to 26-bit mask. So it's a child. It has been subnetted. It's going to be level 2. This one /30 also has been subnetted. /24 again. /24 should have been the default. So it's bigger than the default, meaning it has been subnetted. So it's level 2. How about this one? Look at the same network, 2.0, same network. Now it's the class 4, default subnet mask 24. This is going to be a parent because this parent has been subnetted into these two. So I'm not going to call this one just a level 1. I'm going to call it level 1 parent. There you are. Let's check. Okay, so we got all good. Next. Okay, route lookup process. How a route is looked up in the router. Okay, so when a packet is coming to a router looks at its destination address. In the destination address, so okay, the destination network is that network. Okay, do I have that network in my routing table? So try to find a match in the routing table. Okay, if a match is found, yeah, this is the destination network is going. It's an ultimate route. Ultimate route means there is a next hop or an exit interface is there. So just send this packet through that exit interface and we're done. Simple. Okay, level 1 routes. Okay, what about, that's number one. That's what router does. If a match is found and that match is an ultimate route, just send them through that interface and we're done. If the best match is a level 1 parent route, then proceed to the next step. Because a parent route would not have a an exit interface. So you could not send. So go to the next step. Then you figure out if there is a child that matches. When you have a parent that kind of matches, the child will probably match more specifically to the specific subnet. And then you send through that interface. Okay. If there is no match with even the child, then what you do? Then you just see if there is a lesser match, like a supernet, like any other match. If not, then you go for the default route. That hey, if there's a default route, nothing is matching, so I go through the default route. And if nothing matched, not a parent, not a level 1 ultimate route, not a child ultimate route, not if there is no default route, then router is going to drop that package. Okay. So here, matching level 2 child routes. One of these will match. Okay. One of the exact subnet is going to match and send it to that particular subnet as opposed to going to the parent. This parent is going to be so ambiguous, so obscure, because this parent is not really a network anymore. This parent has been subnetted into many different subnetworks. So a packet has to go to one of the subnets. That's why if there's a parent route, you don't send to there. You look for then each child to go to the specific network. Okay, that's simple. And if there's no child is also matched, then you say, well, no match. Is there a 0000 default route so I can go through there for the unknown networks? Then you say, yeah, there is. So go, then take the default route. Or if you say that, well, there's no default route, then what do I do? Router is gonna drop the package. Okay. Next, best route is the longest match. If there are so many entries in the routing table, like these, 172.16.0.10, 00, 0018, all these different kind of network, several routes. You check a destination packet, a packet's destination IP address will match the longest in binary with which one. Whichever is the longest match, you take that route. See, this one is the longest match, a specific subnet, 26-bit mask. That's a very small subnet that matched, so that's the longest match. That's going to take you to the specific network. Okay, so I'm not going to go through this math binary. Just do that. Don't worry about it if you didn't do it. Next, IPv6 routing table. Now we take a little moment. So far we have been discussing IPv4 routing table entries. How do the entries in an IPv6 routing table look like? Let's see. That's how it looks like. Okay. This is an IPv6 routing table. What we did, we typed show IPv6 route. And we see, oh, same way. C means connected, L means local, D means EIGRP, C means connected, L means local. And then the destination network. It's a network address. Okay, I got that. Then this administrative distance and the metric, we understand that too. Then this via gigabit 00, that's my exit interface. It's directly connected. So it's same thing, same way, same kind of entry. Okay. And directly connected is with C and L, same. So it shows the same thing that I just discussed. We can just move on. For a remote network, not a local network, remote network would be the same idea that we had with the IPv4 again, same thing. It has a little bit more information. For example, this one. So look at this D. D means EIGRP. So this route was learned via EIGRP protocol. What is the destination network we're talking about. This is the destination network. What is the administrative distance of this route? 90, because EIGRP has administrative distance of 90. What is the metric? It's a long number, huge number, big number. It's not as preferable metric wise via this interface. Okay, via this next hop. Next hop IP address is a local link address, link local address, FEAD3, and serial 0001 interface. Here is the IP address, and here's the interface name. Okay, that's the next hop. Next hop IP address and exit interface. Okay. Next. Let's see if we understand this one. Identify parts of an IPv6 routing table entry. Okay, we want to identify the different parts of the entry. Simple. Okay. Specified network in this case, 2001 DB8 Cafe A001. So let's look for that network, whatever in this table, whatever that network is. A001, Cafe to Cafe, right here. This is the one, Cafe A001. So that's a C, directly connected. Okay, so route source should be C, directly connected. So it's a connected route source. Administrative distance, here's the Cafe 001 right here. Administrative distance is 0 right here, and the metric is 0. So it's directly connected, of course, admin distance is 0. Outgoing interface, which interface is going out? This Cafe serial 000. So I go to the serial 000 right here. That's my exit interface. That's it. I was able to do this first one. So let's check. Good, we did good. So I wanted to do this number 2, number 3 by yourself, the same, using the same principle. Next. That's it. End of the chapter. So we have just finished chapter number 3. So what I want you all to do is what I wanted to do. Right now is 2 o'clock. Okay, I'm gonna again come back today at 2:30, and I'm gonna do another lab. So I want to make sure that 4 labs are done today, and because today, at least up to today, 4 are done. 2 are done before, 1 we did earlier, and I'm going to do 1 more at 2:30, exactly 30 minutes from now. I don't mind giving just a, let's see, right now it's 2 o'clock, right? Just a 15 minutes break. Only a 15 minutes break, end at 2:15, okay? So let us end at 2:50, sorry, let us take a break right now, come back at 2:15 again, and do the lab. Next lab, and the next lab would be, let's see, which one is the next lab? Next lab is 3218. That's the one. Okay, my friends, so I'll see you soon. Thank you.